Welcome back to my channel, guys. Today we are going to be talking about how to solve systems of linear equations by graphing. Okay, so before we can talk about how to solve them, we first got to know what they are. So what is a system of linear equations? I'm glad you want to know. A system of linear equations is when you have more than one equation and the equations are linear. So for example, you'll see, and most of the time they're written in what's called braces. So you may have something that look like this: 3x plus 4y equals 6 and 2x minus 5y equal 10. And so we have more than one equation and they're both linear. How do you know they're linear? Because the highest exponent on the variables is 1 and you have two variables. Whenever you have a system of equations, what you want to do is you want to find the value of the variables, both variables, that make both of these equations true at the same time. So since my variables are x and y, then I need to figure out what are the values, what value of x and what value of y will make this equation true, but also make this one true at the same time. And so that's what we're going to be doing when we're solving systems of linear equations. There are multiple ways you can solve systems of linear equations. You can solve by graphing, by substitution, elimination. You can use matrices. But in this video, we're going to talk about how to solve systems of equations by graphing. Whenever you solve a system of linear equations, if it has two equations in it, then there are three possible different scenarios that can happen. And so the first scenario, or the first case that can happen, is you can have two separate graphs. So here's one of my graphs. Because it's a linear equation, when you graph it, it's going to be a line. So you have two separate graphs that intersect, and they intersect in one point. The point where they intersect is the solution to that system. So that is the point, the x and y value, that makes both of those equations true at the same time. So if you have two graphs that intersect in one point, that one point is your solution. We call this a consistent system. Consistent means that there is a solution, and then it's called independent because the lines are independent of each other. In this case, there is one solution. Okay, so that's the first case of what can happen. The second thing is that we can graph two lines and they can be what we call parallel to each other, which means they never intersect. So if the lines are parallel, they will never cross, which means there is no point that they share. So that means there's no solution in this case. So if you end up with two lines that are parallel. Now, when we talked about slope, if you recall, talking about slopes of lines, we know that lines are parallel when they have the same slope. So if you want to make a note here, these are lines with the same slope. So this is no solution. We call this an inconsistent system. So remember, consistent means that there is a solution. So inconsistent means there's not a solution. And then these lines are also independent of each other. They're doing their own thing. So this is terminology that's used to describe these different systems. The third system is you can graph two lines and they can actually be the same exact line, meaning they lie on top of each other. So they could be the same exact line. In that case, every point on the lines is a solution. So there is infinitely many solutions in this case. There are infinitely many solutions. This is called a consistent system because there is a solution. There are a lot of solutions actually. And this one is called dependent because the lines are dependent upon each other. They're the same exact line. So these are the three different situations that can happen. Again, you can have one solution, you can have no solutions, or you can have infinitely many solutions. So when you're solving your systems of linear equations, if there's two equations, you're going to have one of these cases. So let's look at some examples of solving systems of equations by graphing. For this first example, we don't actually want to solve the system. We just want to check to see if 4, -3 is a solution to this system. So if you want to check to see if it's a solution, then all you do is plug the numbers in. This is an ordered pair. This is your x and this is your y. All you do is plug those numbers in and see if it makes both of the equations true at the same time. So if I'm testing the first equation, x plus 4y equal -8, I'm going to replace x with 4, and I'm going to replace y with -3. And then the question is, will this come out to be equal? So here I get 4. 4 times -3 is 12. So again, I don't know if that's equal. I'm checking to see if it's equal. 4 minus 12 is -8. -8 does equal -8. So this ordered pair makes that first one true. But I can't automatically assume that it is a solution. I have to also check the second one. So now I need to check the 3x plus 2y equal to 6. This time I'm going to replace x with 4, and I'm going to replace y with -3, just like I did before. And I don't know if that's equal. I put a question mark on top of the equal sign because I'm checking to see if it's equal. 3 times 4 is 12. 2 times -3 is -6. 12 minus 6 is 6. 6 does equal 6, so yes, it checks out. So since this ordered pair makes both of these statements true, then we can say yes, 4, -3 is a solution. And so that's all you would have to do to check to see if it's a solution. For example 2, we actually want to solve now by graphing. And so we want to solve this system 2x plus y equal 2 and 2x plus y equal 8. Now, if you recall, when we graph linear functions or linear equations, we had to first get it in the form of y equal mx plus b. That was the slope-intercept form, which means we need to take each of these and solve it for y. So I'm going to take each equation and work on it separately. So for this equation, 2x plus y equal 2, I need to get y by itself. So I'm going to subtract 2x from both sides. And so I get y is equal to -2x plus 2 because that's a positive 2. So now looking at this, it's in y equal mx plus b form. I can graph it by looking at the slope, the number in front of the x. So the slope is -2. And looking at the y-intercept, which is the other number, the b is the 2. And so I will do the same thing here. I want to solve this for y. So move the 2x over. I get y equal to -2x plus 8. So now it's in y equal mx plus b form. So the m is the number in front of the x. That's the slope. So the m is -2. The y-intercept is the other number, which is 8. So now I want to graph each of these equations. So if I start with this one, the y-intercept is 2. Remember, we always want to start the y-intercept when we're graphing. So I'm going to go over here to 2. This is my red equation. So I'm graphing this in red. Go to 2 and put a point. The slope is -2. Remember, if you write the slope as a fraction, that's -2 over 1. So that means I would go down 2 over 1. Down 2 over 1. And you can keep repeating that process, down 2 over 1, as long as you need, but you only really need to do it at least 3 times to get 3 points on the graph. My line's a little crooked, but just imagine it's straight. And so that's this equation right here. And so I'm gonna do this equation in green. The y-intercept is 8. So if I go up to 8, 1, 2, 3, 4, 5, 6, 7, 8, put a point. The slope is also -2. If I write that as a fraction, rise over run. Remember, slope is rise over run. So that means I go down 2 and to the right 1. So down 2 over 1, down 2 over 1. And we get a line that looks like this. So if you look at those lines, they look like they're parallel to each other. If you're not for sure, look at the slopes. The slope of this one was -2 and the slope of this one was -2. So since the slopes were the same, that means the lines are parallel, which means there is no solution. There's no solution to this system. And if the question asks you, if you're asked to describe the system, this will be considered an inconsistent system. You may or may not be asked this, but just so you know, that's the inconsistent system because there is no solution, and it will be considered, the lines will be considered independent. So depending on your homework platform, it may ask you about that or not. But this is an example of a system with no solution. So in example 3, we're going to do another example where we solve a system by graphing. Our system this time is 2x minus y equal 4 and 4x plus y equal 2. So remember, if I want to graph each of these, I got to get it in slope-intercept form, which means get y on the side by itself. So I'm going to take both of these equations separately and solve them both for y. So this one, if I want to solve it for y, I would subtract 2x from both sides to move the x to the other side, and I get negative 2x plus 4. But this this negative stays in front of the y. So I need to get rid of this negative in front, and the way I do that is divide everything by -1. So essentially all I'm doing is changing the sign of everything. So this becomes y equal a positive 2x minus 4. That 2 was negative, it now becomes positive. That 4 was positive, it now becomes negative. And so this equation is y equal 2x minus 4. It's in slope-intercept form. The slope is the number in front of the x, which is the 2. The y-intercept is the other number, which is the -4. I'll do the same thing over here, get y by itself, so get rid of the 4x. So that means I need to subtract 4x from both sides. I get y is equal to -4x plus 2. So now it's in slope-intercept form. The slope is the number in front of the x. That's my m. M stands for slope. The y-intercept, which is b, is 2. So now I can graph each of these. Okay, now we can graph each of these equations. So we're going to start with this one. So with this equation, our slope is 2. Our y-intercept is -4. So we're going to start with the -4. I'm going to graph this one in red. So go to -4 on the y-axis. 1, 2, 3, 4. And put a point. That's your y-intercept. The slope is 2, which is equal to 2 over 1 as a fraction. That means you rise 2 and you run 1. So go up 2 over 1. Up 2 over 1. So I went up 2 over 1, up 2 over 1, and we get a line that goes through those points. So that's the first equation. The second one, I'm going to graph it in blue. Our y-intercept is 2, so I'll go to 2 and put a point. Our slope is -4, which is equal to -4 over 1. That means to go down 4 and over 1. So if I go down 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1, we get a line that looks like this, and you can clearly see the points intersect here at 1, -2. And so that means that our solution is 1, -2. That's where they intersect. Our x is equal to 1 and y is equal to -2. So depending on your homework platform, it may want you to write the x and y separately, or it may want you to write as an ordered pair. Again, you could go back and check to make sure that works by plugging it back into each of those equations. Also, if you had to describe the type of system it is, since there is one solution, then this would be considered a consistent. Consistent means there's a solution, and independent system because the lines are independent of each other. So again, this is the system that has one solution. It will be called a consistent independent solution. Hopefully y'all can see that. Sorry, I wrote it over my graph. Okay, let's solve one last system by graphing. So we're going to solve this system 2x minus y equal 4 and x equal y over 2 plus 2. So what I want to do is I want to take each one of these and put it in y equal form. So 2x minus y equal 4. That means I need to get y by itself. So I'm going to subtract 2x from both sides. That gives me negative y equal negative 2x plus 4. I need to get rid of this negative by dividing everything by -1. And I get y is equal to 2x minus 4. Alrighty, so here the slope is the number in front of the x, which is your 2. That's m. And then your y-intercept, which is b, is the other number, which is -4. So this is this equation in slope-intercept form. So now let's get this second equation in slope-intercept form. So I need to get y on the side by itself. So I am going to subtract 2 from both sides. I get x minus 2 equal to y over 2. Then I need to get rid of this 2 in the denominator. So I'm going to multiply both sides by 2. Because this is y divided by 2, and the opposite of division is multiplication. So that's why you multiply. Well, the 2's will cancel here, and you get y equal, even though it's on the opposite side, distribute the 2. You get 2x minus 4. So you get y equal, if it makes you feel better, you can rewrite it. Y equal to 2x minus 4. The slope is the m, or the number that's in front of the x. and the y-intercept is the other number. Now, you can look at these and see they have the same slope and the same y-intercept, which means when you go to graph them, the y-intercept is -4, go down to -4. The slope is 2, which is 2 over 1. Go up 2 over 1, up 2 over 1. You get this line. But if you graph this one, it has the same exact y-intercept and the same exact slope. So what that tells you is that these lines are the same. There are two lines that are the same, which means every point on that line is a solution. So there is infinitely many solutions. So this is the case where it is a dependent, consistent system. Depending on your homework platform, it may want you to write infinitely many solutions, or some of them may want you to write your answer like this. It's the set of all x, y such that, and then you will put one of these equations, 2x minus y equal 4. That's just saying every x and y in this equation is a solution. So this is how you will work this example. So if this video helped you in any kind of way, please hit the like button, share it with someone else you know taking a class similar to this or that it might be helpful with. And if you haven't already, make sure you hit the subscribe button. And if you want to know when I release new videos, you can hit the bell button and you'll get notifications. So thank you for tuning in, and make sure you go watch the next video, which is solving systems of equations by substitution.